the only thing which I wanted to tell you is to finish this stuff with the linear systems of linear equations is the following. Homogeneous systems. So, homogeneous system is the system, okay, definition. System of linear equations is the system with zero right-hand side. So, in other words, if you have augmented matrix will look like that. And here you can have something. So obviously, there is no sense to have augmented matrix, which means matrix with a zero column, because as you can easily understand, all elementary row operations with zero column will give you still zero column, right? So you can exchange zeros, multiply them by non-zero number, whatever you like, essentially. So as a result, there is no sense to keep it. And usually for homogeneous system, we use just augmented matrix, changes into just coefficients matrix. Okay, A11x1 plus A12x2 plus and so on plus A1nxn equals to 0. A21x1 plus A22x2 plus and so on plus A2nxn equals to 0. AM1x1 AM2x2 plus AMnxn equals to 0. Okay, so this is a general m by n system of linear equations, homogeneous, because it has zero right-hand side. Pay attention. Okay. Could you please tell me, is this system consistent or not, regardless of coefficients?
Yes.
Okay. So could you tell me what will be the solution?
Solution could be zeros.
Yes, exactly. So x1 equals to x2 equals to and so on equals to xn equals to 0. This is so-called trivial solution of homogeneous system of linear equations. So you can say that it's definition. Okay, great. So now it means that homogeneous system is always consistent, right? So now if number of unknowns, n, right, strictly more than number of equations. What can you tell me about a solution set of this homogeneous system?
Is it many solutions?
Pay attention that because we can either have, so when we have many solutions, when we have a free variable, right? Right?
Yes. Right.
So, but if you have more unknowns than equations, you cannot have all variables to be just, pay attention, strictly more. Strictly more. So you cannot have all variables to be the leading ones, right? You just don't have enough corresponding to the leading ones in the, for example, row echelon form, right? Because you don't have enough rows in your matrix to have all of your variables or all of your unknowns to be leading ones. So it means that inevitably there will be at least one free variable, right? Is it clear or not?
Yes.
Yes.
So, but if there is a free variable, it means that this variable can take whatever, okay, in our case, real value, right? And what does it mean? It means that we have infinitely many solutions. Is it clear or not?
Yes, for me.
So we can even formulate it as a theorem, second theorem in our course, right? So if number of unknowns strictly more than number of equations for homogeneous system of linear equations, then we have infinitely many solutions. Pay attention that this works only for homogeneous system of linear equations, right? So because as we know, if we have inhomogeneous, so which means with non-zero right-hand side system of linear equations, it can be inconsistent, while homogeneous system of linear equations is always consistent because it always has a trivial solution.
Can I
Clear or
ask a
not?
question?
Yeah, go ahead.
So you said that for non-homogeneous systems, this isn't always true, but does that mean that there are cases where this is true?
I mean, of course, I can just
You don't have to do an example or anything. I just wanted to clarify.
no. It's easy to do an example, really. So have a look. If I have this, right? So obviously, I mean, I can say that this is a system of linear equations consisting of just of one equation, right? Right or not?
Yeah.
Yeah. So then I know that this equation has infinitely many solutions, right? Because this is nothing else but the plane in three-dimensional space. So you can, I will show it later, but you can just consider it as a plane. So in three-dimensional space. So plane has infinitely many points, right? So that's it. Now, I can tell you the following, that if system of linear equations is consistent, pay attention, this is important, consistent, right? So it means it has at least one solution, right? And number of equations is less than number of unknowns, then inevitably you have infinitely many solutions. Why? Because if it's consistent, it means that at least one solution exists, right? But if you will bring it to the row echelon form or reduced echelon form or reduced row echelon form, so what it means? It means that inevitably there will be at least one free variable, right? Clear or not?
Yes.
So the only problem with inhomogeneous systems, which means, or non-homogeneous if you like, so is that they can be inconsistent. So for example, how to get inconsistent system starting from here. So this is a system which has more unknowns than equations, right? But this system is inconsistent because these are really two parallel planes. So they do not intersect anywhere. Clear or not? Okay. So, but if I will do something like that, for example, right? So I can see that this system is consistent because these are two coinciding planes, right? So, and it has infinitely many solutions. Is it clear or not?
Yeah.
Okay. So what is good about a homogeneous system of linear equations? It always consistent because it always has a trivial solution. So, or zero solution. So one could say that, yeah, but why we are studying these strange systems of linear equations, and why? I mean, what for? Do they have any applications? Of course they do. And many of these applications are listed in your book. So this book is good specifically because it has a lot of applications of every topic which we study essentially listed. But let me give you another one. Let us suppose that I just want to tell you that the guy, of course, for a little bit more involved model, but still, the guy got a Nobel Prize for that, Nobel Prize in economics. So let us consider a tribe, right? Or we know that if you studied even on the elementary level history, so you know that originally our economics was based, and this is natural, right? So on so-called natural exchange. So it means that, for example, you went to the forest and found some tasty root, or for example, you were able to caught, let's say, a rabbit, right? But the problem is that you need, let's say, the new cloth, right? You have a rabbit, but you need new clothes. So then you go to the person who has, let's say, more clothes than this person needs, and exchange the rabbit, right, on this, for example, pair of pants or something like that, or shoes or whatever. So this is natural exchange, when you exchange the goods for goods. The only problem is that it's not very convenient. So why it is not very convenient? Because, for example, right now you have some extra food, and but you need, let's say, I don't know, maybe maybe a javelin to get even more food, right? So the thing is that in this particular moment, there can be nobody in your tribe who has extra javelin, but there can be somebody in your tribe who has extra pair of pants. Okay, you already have enough of clothing, but you cannot exchange essentially your specific extra goods for what you really need right now. But what you can do, you can exchange it for, let's say, for pants, and hope that in the future somebody will have extra extra javelin, and this person will be will agree to change it, to exchange it for these extra pants which you have. But what is good that you can exchange food, which is usually perishable, for something which you can store. But you see, it's not convenient, because you essentially need to have a situation when there is a person who agrees to change what you have for what you need. And this can be not the case for quite some time. So as a result, it's good to have universal exchange unit, right? And this universal exchange unit, usually it has to be something rare, because otherwise you could just go to the place where you know that there is a lot of this stuff and just get it without producing anything, right? Producing any goods. So this is really a concept of this universal exchange good, right? So which everybody needs all the time, in a sense that because you can exchange it to anything, because it's universal, right? So this is a concept of money, really. So, and the thing that it has to be rare, for example, it can be, and I believe originally this was some extremely rare shells, for example, from the sea. So if you live far from the sea, they are extremely rare, and as a result, you can use it as money. Or if you ever played to video game Fallout, for example, right? So which tells us about this post-apocalyptic world after the Third World War. So they used, for example, the lids of analog of Coca-Cola bottles as money, because you have finite resource, right? So, and they're getting rare pretty fast after you introduce them as universal exchange good, right? So that's it. Or in a modern situation, we have one emission center, for example, in the country, which can print money. And you see, all the money made of not so hard to get good, like let's say paper, right? So, but the thing is that they are done in such a way that it's hard to reproduce it, and it's even punishable by law because of that. So you introduce some universal exchange good. The question is how to introduce it. And here is a model. Let us suppose that we have farmers, manufacturers, and cloth makers. So these produce tools. These farmers produce food. Clothing makers obviously produce so now let us suppose that, and this is usually the case, right? So that we have farmers, manufacturers, clothing makers, farmers, manufacturers, clothing makers. Okay, farmers produce some amount of food. Half of this amount of food they leave for themselves because they need to eat something, right? Quarter of this amount of food they give to manufacturers of tools. Why? Because they need tools, right? So, for example, they need a plow, they need to, for example, tools to process the crop, and so on and so on. And also, for example, in our part of the country, it's hard to walk without clothing during the summer and hard to walk without clothing during the winter. During the winter, it's too cold. During the summer, you need to protect yourself from sun, right? Too hot sun. So as a result, farmers also give 1/4 of the crop to the clothing makers. So pay attention that altogether, sum gives you 1, the full crop, right? So this is important. Okay, now manufacturers of tools, they just give 1/3 of the tools which they produce to farmers in exchange for food, obviously. They leave 1/3 of the tools to themselves because they need tools to produce tools, right? So because tools usually they have finite resource, right? So, and they give 1/3 of the tools they produce to the clothing makers, right? And altogether, you see that it gives us sum 1. So essentially, they spend, so they give somewhere and leave to themselves the whole, the total number of tools they produce, right? Okay, clothing makers, because there are a lot of farmers, so you need to give half of the clothing you produce to them. And there are not so many manufacturers, so as a result, you give 1/4 to the manufacturers and 1/4 you leave to yourself because you also need some clothing to walk in the sun or to walk during the winter, right? So again, altogether, the sum is 1. Okay, so how you can write it? So farmers, let us say that X1 is price of food, all food. X2 is price of all tools, and X3 is the price of all clothing. Okay. Okay. Now, if we have a fair system, So you see, this is what farmers get, right? Farmers get 1/2 of all the food, plus farmers get 1/3 of all the tools, right? Plus they get 1/2 of all the clothing. If we have a fair system, so they supposed to get according to what they produced, right? Like that. So pay attention. This is the essentially, we don't know what is the price, right? So what does it mean? So, but essentially we are saying that this is the cost of all goods for farmers, right? So, and we are saying that, let us suppose that we consider a fair system, or what we call fair, that the cost of all goods for farmers is equal to the cost of the food they produced, right? Is it clear or no?
Yes.
So it makes some sense at least. Okay, good. Okay, now manufacturers, they get
I had a question.
1/4. Yeah, go ahead.
Is the left-hand side equal to the right? Because all of the people, the farmers, manufacturers, they're trading everything that they have. And like if one person didn't trade everything, then these two wouldn't be equal?
Yeah, usually you do it like that. So you're saying that, so you see, this is price of all the crop which farmers got, right?
Right.
So inside of this group, you can build more or less the same model later. So for example, somebody produces potatoes, somebody produces wheat, and somebody produces milk, right?
Yes.
So, and you can say that, okay, altogether, this costs that much, right? So it means that so that many liters of or quarts of milk costs X1, plus that many gallons of wheat costs that much, right? X2, let's say, and so on. So, and you can say that, okay, this equality, right, equals to the total price of the crop, right? And then essentially you can do the same model inside of the farmers group. So, and because you also need to redistribute, for example, all the tools which farmers get inside the farmers group as well, right? And all the clothing which farmers get, you need to redistribute it inside the farmers group. So essentially, as I'm saying, so this, what I'm writing is a simple model, but later you can make it more complex because you can use the same model inside of every group: farmers, tool makers, and clothing makers. Okay?
Okay.
Is it clear?
Yeah.
Okay. So, and then of course, if somebody is not working and producing practically nothing, then of course it depends. So, because we know that already even ancient people, even Neanderthals and Cro-Magnons, they were caring about people who were not producing anything. So they were caring about this. But this is more complex already than the model which we are considering. So let us suppose that we are just talking about the groups, right? Okay, so now manufacturers, they get 1/4, this 1/4 of all food. Then they use 1/3 of all tools, right? Plus they use 1/4 of all clothing, right? Here it is. So, and let us say that in order for the system to be fair, it has to be equal to the price of all tools they produced, right? Okay, so, and this is cost of all goods for manufacturers. And clothing makers, so they get 1/4 of all food plus 1/3 of all tools plus 1/4 of all clothes. And we suppose that system is fair, so that the price of what they produce is equal to price of what they get. So you see, we got system of 3 equations, right, for 3 unknowns. Okay, now let us convert it to the form of the linear equations which we are used to. Let us move all this x1, x2, and x3 to the left-hand side. Then we are getting the following. So minus 1/2 x1 plus 1/3 x2 plus 1/2 x3 equals to 0. Here 1/4 x1 minus 2/3 x2 plus 1/4 x3 equals to 0. And here we are getting 1/4 x1 plus 1/3 x2 minus 3/4 x3 equals to 0. So this is a homogeneous system of linear equations, right? Obviously, it has trivial solution, but this trivial solution is not interesting to us, right? Why? Because essentially you can say that everything costs nothing, and then you cannot introduce a price, right? So it's if x1 equals to x2 equals to x3 equals to 0, so you cannot introduce a price. So as a result, this is just not convenient, right? So it's exactly the opposite to what you're trying to do. Okay, in order to solve this system of linear equations, pay attention, I don't need to write the right-hand side, so it's enough to consider just coefficients matrix. Just this, right? And okay, let me just, so you now know already how to perform Gauss-Jordan reduction. So let me bring it to the reduced row echelon form. Okay, essentially what could I do? So I could, for example, multiply the first row by -2. And then we are getting 1, -2/3, -1. So, okay, also let me just multiply this by 4 and this by 4 to simplify it a little bit. So I will get 1 negative 8/3 1, and here I will get 1 4/3 negative 3. Okay, now I will use this as a pivotal row, right? So it stays the same, 1 negative 2/3 negative 1. I will subtract it from, we'll replace the second row with, if you like, the sum of the second row and the first row multiplied by -1, or I can say that I will replace the second row by the difference of second row and the first row. So this will give me 0 here. Negative 8/3 plus 2/3 will give me negative 6/3, right? Or negative 2, right? And in the last, in the third column, I will get 1 minus -1, 2. Okay, so also I will subtract the first row from the third one. I will get 0. 4/3 minus -2/3. So will give me 4/3 plus 2/3, 6/3, so which is 2. And -3 plus 1 gives me -2. Okay, so I can multiply these by -1/2 and these by 1/2. So as a result, I'm getting 1 minus 2/3 minus 1, 0, 1 minus 1, 0, 1 minus 1. Subtracting, I'm getting 1 minus 2/3 minus 1, 0, 1, -1, 0, 0, 0. So this is row echelon form, right? But I don't want to stop here, so I want to continue. So to perform Gauss-Jordan reduction, so I will multiply this by 2/3 and add. So Gauss-Jordan reduction means that I need to get of all entries over on top of leading ones, right? So in other words, I'm trying to get rid of that, right? So 0, 0, 0 stays, 0, 1, -1 stays. So, and here will be, okay, 1 of course will stay. So here I will get 0, and here I will get -1 plus -2/3. So -1 is nothing else but -3/3. So -5/3 as a result. So this is reduced row echelon form, right? So from here I can write the following equation. x1 equals to 5/3 x3, x2 equals to x3, right? And x3 equals to something, alpha, right? So, or I can do it like that. Okay, if you are using some universal unit of exchange, so it's in most of the cases, it's convenient to consider not fractional, but integer number or even natural number of units for exchange, right? So it means that x1 has to be related with x2 and x3 has, for example, let me choose alpha equal to 3. So it will be 5, 3, 3. And of course, alpha can be not only 3, but 300, 3000, whatever, right? So it means that if manufacturers, for their all of their tools have to get, let's say, 3 buckets of whatever, seashells, for example, or leads from New Coca-Cola, as in Fallout video game. So all cloth makers supposed to get 3 buckets of the same good, and all farmers supposed to get 5 buckets for all their crop. So we introduced the simple model, which allows us to essentially exchange, to introduce money, so universal exchange good for the tribe. So of course you could create it, you could write it differently. You could say that, okay, let us separate all the farmers into subcategories, right? So, and then you can say that I'm not considering just farmers, I'm considering specifically the farmers who work with animals, right? Farmers who produce wheat, farmers who produce potatoes, and so on and so on. And then your system of equations will include more unknowns, but idea will be the same. So Vasily Leontiev got a Nobel Prize for introducing models like that. So it looks simple, but idea is that you take the problem and you create mathematical model for that, mathematical description. And of course, it can be used for whatever number of different groups and correspondingly differently produced goods. Okay, is it clear or not?
So I have a question.
Go ahead.
What was it that ensured that we would necessarily have a free variable in this? Because if we didn't have a free variable, the only solution would be the trivial solution, which wouldn't really be useful.
Yeah, I mean, I agree with you. So what ensured that, okay, I can tell you what ensured that, because we introduce it in such a way that you see sum was getting to 1, right? So the proportion. So there is inside of these 3 equations for 3 unknowns, right? So these unknowns, they are not free, really, because really there is a conservation of goods, right? Because you produced this amount, right? And then sum of all these fractions gives you 1 specifically. So these coefficients, they are really not random, right? Already. So exactly this additional constraint which is inside of the system on the coefficients, it gave us a situation when we know for sure that there will be infinitely many solutions, so there will be free variable. Is it clear?
Yes, thank you.
So essentially, these coefficients, they are not random. So they have a constraint, all these coefficients. Pay attention that if you compute the sum, right, sum always gives you one of these coefficients. So, and these really ensures that, that you will have you will have non-trivial solution. Yeah. Okay. Great. Now, let me introduce a simple thing. So, but it's just convenient. So we will use it later. Okay. Really, I can postpone it. So let me formulate the theorem. So. Okay, I spent maybe too much time on this example of application. Okay, I believe I will be able to do this. Any linear systems solution set has the form P plus C1 beta 1 plus and so on plus CK beta K C1 C2 CK are real numbers where P is any particular solution. So particular solution means that any solution you can find. For example, you guessed it or something like that. And where the number of factors beta 1 beta k equals the number of free variables that the system has after Gaussian reduction. Okay. We will prove this theorem a little later using corresponding lemmas. Lemmas are the statements which you need to prove, but they are not so, essentially not so important. We will use this theorem, and these are just auxiliary statements which are used to prove the theorem. So let me give a definition. So a linear combination is homogeneous if it has a right-hand side of 0. So in other words, it can be written as A1x1 plus A2x2, so plus ANXN equals to 0. Okay, I will stop here.